In this video, we're going to introduce you to how to graph some simple rational functions. Now, in general, rational function is something of the form f of x equals p of x over q of x, where let's say p of x is just any polynomial, and so is q of x. So you just have some fraction, right? Some rational expression to create your function. Now in this section there's going to be two types. The first one is actually inside of this box here, and you'll notice it has an h and a k value, which worked for the last few sections. We talked about horizontal and vertical shifts, and technically we can still do some horizontal and vertical shifting and look at like a parent function and move it. However, there's going to be a little bit more easier of a way in this section, I think, to think about it rather than like horizontal and vertical shifts, although we could do that if we wanted. And then the second type I'll show you on the next slide. Let's start with a few like these. When you have the form y equals a over x minus h plus k, you're going to have a vertical, and I think it's the first time we've seen a vertical asymptote, and we'll talk about why when we actually graph one. You're going to have a vertical asymptote at x equals, let me get rid of some of this box here. You're going to have a vertical asymptote at x equals whatever that h value is. And you're going to have a horizontal asymptote at y equals k. Notice how the vertical asymptote, of course, has the form x equals, and the horizontal one has the form y equals. If you remember that goofy expression vux hoi, that helps you remember the format for vertical and horizontal lines like we talked about before. Note that the vertical asymptote is simply the value of x that makes the denominator 0. If you think about it, if you plug in h for x, or let x equal h, that general expression would become the following. You'd have y equals a over, instead of x minus h, I can write h minus h plus k. And notice h minus h, of course that's going to be 0. So you're going to have a over 0 plus k. And you might remember, you guys can't divide by 0. We talked about when we were doing function operations back in chapter 7. Whenever you divide by 0, we have an undefined domain. So we can't divide by 0. There is no output when we plug in that value that makes the denominator 0. So we're always going to have a vertical asymptote whenever the denominator is 0. And that's actually going to come into play again and again in this chapter. Step 2, we're going to plot a couple of points on each side of the vertical asymptote. And we're going to see we're going to have two separate, and I call them branches. And this type of graph is called a hyperbola. Okay, so actually everything in this section is called a hyperbola. This is when we have two branches. Actually, they're going to look like two parabolas put together, and I think that's why they use that prefix hyper to mean many. So it's like many parabolas put together here. And what's going to happen, the two branches of the hyperbola are going to approach the asymptotes and pass through our plotted points. Let's take a look at maybe a couple of examples here together. Now, in this particular example, you'll notice we have y equals 2 over x. And if we compare it to that general form, that y equals a over x minus h plus k, you might think, well, I don't see really an h or a k anywhere. I do see like an a value up there. That is your a value. However, there is no h and k. Well, if there is no h or k, that just means the h value is 0 and the k value is 0. Oops, equals 0. So what I'm going to do is I'm going to plot my vertical asymptote at x equals 0 and my horizontal asymptote at y equals 0. So those are going to be just the y-axis, right, if we dash that in, and the x-axis. So those are our asymptotes. Now all I'm going to do for step 2 is plot a couple points on each side of the vertical asymptote. So let's make a quick table. Obviously if I plug in 0 for x, I'm going to get 2 over 0, and that's undefined, right? That's why we have that vertical asymptote there. So we don't get any outputs when we plug in 0. That's not part of our domain. If we plug in 1, however, I'm just going to get 2 divided by 1, which is just 2. So that's the point 1 comma 2, that's right there. If I plug in 2, I'm going to get 2 over 2, which is just 1, and that point is right there. Now just for giggles, we're not going to normally plug in more than that, and you'll see why. But just so you kind of get a beat for what's going on here, if I plugged in 3, we'll get 2/3, which is now 0.7 if we had to round to 1 decimal place. If we plotted that, that'd be right there. And let's just jump to 5. Again, I'm just doing this to kind of illustrate what's going on here. If I do 5, I'd get 2/5, which I believe is 0.4. Notice these values are all getting closer and closer to 0. But if you plugged in, let's say, 100 for x, and we're obviously not going to plot that, I would get the output of 2 over 100, which is really, really, really close to 0, right? That's really close to 0, but it's not quite 0. So it'd just be 2/100ths. So what we have going on here is a graph that's going through these points and decreasing and getting closer and closer to your asymptote going that way. Now, as we move to the left, this is being pushed upwards and gets closer and closer to that vertical asymptote. And just for giggles, for instance, if I were to plug in, let's say I wanted to plug in 1/10, right, or 0.1 for x, I'd get 2 over 1/10, which if you multiplied by the reciprocal would be 2 times 10. I'd get an output of 20. So you can see if you plug in something really close to 0 for x, you get something really, really big. So that's what the first part of the graph looks like. Let me make a continuation of the table over here. If I plugged in -1 for x, I'd get 2 over -1, which is just -2. So -1, -2 would be right there. If I plug in -2, I'd get 2 over -2, which is -1. So that would be -2, -1. That point would be right about there. And something similar is going on. If I were to plug in -5, I'd get 2 over -5, which would be -0.4. So that would be right about there. So something similar is going on. As I move to the left, the graph gets closer and closer and closer to the horizontal asymptote. And as I move towards the right, this is going to get closer and closer and closer towards the vertical asymptote. Notice how these are both kind of like U-shaped graphs. So they're kind of like parabolas, right? They're U-shaped. But there's 2 of them. That's why they call them a hyperbola. So this graph is called a hyperbola. It's kind of neat. There's 2 separate parabolas put together. Okay. Let's talk about the domain and the range. When we talk about the domain has all the possible x values that I can plug into this function and get an output for. And remember, we could not plug in 0 because it was undefined. So I would say all reals, but x should not equal 0. For my range, these are all possible outputs. Now if you think about it, if you look at the first branch, right, this one over here, this one over here that I graphed, that guy, whoa, that was a little bit thicker than I wanted it to be, that covers all positive y values for outputs. But it never quite hits 0, right? It goes up to infinity going that way, but as I move to the right, this thing just gets closer and closer to 0. On the other hand, this branch, that branch covers all negative outputs, right? Every number that you plugged in for x that was to the left of the y-axis gave you a negative output, and it got closer and closer to 0, but never quite 0. So my range is also all, reals besides y cannot ever equal 0. So that's the first graph. Let's take a look at the next one, part B. Here I have y equals 3 over x minus 1 plus 2. Now here you might note my h value is really positive 1. That's what I'm subtracting from x, and my k value is 2. So that means my vertical asymptote is going to be x equals 1, and my horizontal asymptote is going to be y equals to 2. So x equals 1 is going to look something like this. Dash that in. So that's my vertical asymptote, and my horizontal asymptote is going to be y equals 2. So I'm going to dash that guy across the page like so. And now I'm ready to plot some points. Now, when I make my table this time, I can plug in 0 for x because 0 is not the vertical asymptote. If I plugged in 0, the equation would become 3 over 0 minus 1, and then I have a plus 2, which turns out to be just 3 over negative 1 plus 2. That's negative 3 plus 2. I get negative 1 as an output. So 0, negative 1 is right there if we plot that point. I'm only going to plug in one more coordinate on that side of the vertical asymptote, so a good x value to plug in would be negative 1. If I plug in negative 1, I'm going to get 3 over negative 1 minus 1, right? And then add 2. That's going to be 3 over negative 2 plus 2. I know 3 halves, or 3 over negative 2, is going to be negative 1.5, so negative 1.5, negative 1.5, and then plus 2 is going to end up just being positive a half. So if I plug in negative 1, I get positive a half right there. Now, I'm fine, guys, if you only plot 2 points on either side of the vertical asymptote. What this should tell you with those 2 points is, as I move to the right, I'm being forced down towards that vertical asymptote. So I'm going to draw it like that. And as I move to the left, I'm going to get closer and closer and closer to that horizontal asymptote like there. And there's one branch of my hyperbola. Now I'm going to skip plugging in 1, because remember, 1 was my vertical asymptote. So I'm going to jump in and plug in 2. So if I plug in 2, I'm going to get 3 over 2 minus 1 plus 2, which is just going to be 3 over 1 plus 2. That's just going to be 3 plus 2, or 5. So if I plug in 2, I get out 1, 2, 3, 4, 5. That's that coordinate right there. Let's plug in 3. That'd be 3 over 3 minus 1 plus 2. So that's going to end up being 3 over 2 plus 2. That's 1.5 plus 2 to get 3.5. So if I plugged in 3, 1, 2, 3, I get out 1, 2, 3.5. That coordinate is right there approximately. Again, all you need really is 2 points for me, and you should know how to graph it. As I move to the right, I have a branch of a parabola that's moving closer to the horizontal asymptote, y equals 2, and as I move to the left, I'm being forced upward towards the vertical asymptote. Let's look at domain and range. Domain is going to be all x values, but x cannot be equal to that vertical asymptote value, which was 1, right? So x can't equal 1. And my range, I get all possible outputs greater than 2 with the first branch and less than 2 with the second branch. So my range is going to be all reals, but y cannot equal to 2. And we're done with that. I'm going to ask that you try part C now on your own, and we'll check that one in class. This one's a little bit trickier, only because you have a negative here, but that's just going to come into play when you make your table of values. Be careful about your evaluation of your table. So I'll let you try that, and then continue on in a moment with the following type of hyperbola. Okay, now to finish up, you're going to have hyperbolas that are going to be of the following form: ax plus b over cx plus d. Basically, you have the equation of a line over a line. It's just a linear polynomial. Graphing these is a little different. There's not just an h and a k value. Basically, the vertical asymptote of the hyperbola is going to occur when the denominator equals 0. So basically, we're going to set the denominator equal to 0 and solve, and you'll see that in a moment. The horizontal asymptote is just going to be the line y equals a over c. It's the ratio of the leading coefficient a, that's the number in front of x in the numerator, and see the leading coefficient of the denominator in the bottom. That's going to end up being our horizontal asymptote. And we'll kind of take a look at why that is, maybe in class, and maybe you can think about why is it that as we plug in huge values of x, really big values of x, y gets closer to that ratio of a over c. And again, we'll talk about that in class, but for now let's just go through and make sure we know how to graph these things. If you look at a, we're going to graph y equals x minus 2 over 3x plus 3. Clearly this is not the same form as the first couple of examples that we took a look at. What I'm going to first do is find my vertical asymptote. So to find my vertical asymptote, what I have to do is set the denominator, which is 3x plus 3, equal to 0, and I have to solve that. And it should be relatively easy to do. If you subtract 3, you get 3x is negative 3, and if you divide by 3, you'll get x is negative 1. That's our vertical asymptote. So let's dash that in. Oops. Dash, 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 dash. So there's the vertical asymptote. Now to get the horizontal asymptote, all I have to do is look at the ratio of leading coefficients, which in the top, the number in front of x is 1, in the bottom, it's a 3. So it's just the line y equals 1/3. So that's a horizontal line that's up 1/3 of a unit above 0. So we're just going to try to sketch this as best we can. So it's approximately something like that. It's not the x-axis, right? It's a little bit above it. The line y equals 1/3. So there's our horizontal asymptote. To finish this off, guys, we're going to do the same thing we did before. We have to make an xy table and just plot a few points on either side. Let's plug in 0 for x first. That's the first x value to the right of the vertical asymptote. If you plug in 0, you're going to get 0 minus 2 in the numerator, and in the bottom, you're going to get 0 plus 3, right? So that would be negative 2/3. So when we plug in 0, we would get negative 2/3, which is about right there. And if we plug in 1, we're going to get 1 minus 2 in the top, and in the bottom, we're going to get 3 plus 3. So that's going to be negative 2 over 6, which reduces to negative 1/3, which is even closer to the x-axis. Negative 1/3 would be something like right about there. Now you could plot more coordinates as you go to the right, but what I think you're going to find is these values get closer and closer and closer to your horizontal asymptote like that. And as you move to the left, this thing's going to have to drop downwards towards the vertical asymptote. So it looks like that. So it's a very sharp bend there. Make sure you don't have any edges on your curve. It should be a nice smooth bend. And we're done with half of our graph. Now let's plug in, we don't want to plug in negative 1, that's our vertical asymptote. Let's plug in negative 2. If we plug in negative 2, the numerator would be negative 2 minus 2 over, and in the bottom we'd have 3 times negative 2 plus 3. So we'd have a negative 4 in the top, and in the bottom we'd have a negative 6 plus 3. That's going to be, what, negative 3. So a negative divided by negative is a positive 4/3, or 1 1/3. So if I plug in negative 2, we get positive 1 1/3. So negative 1's there, negative 2, and then 1 1/3 would be approximately right here. Let's plug in one more coordinate. Let's plug in negative 3. That'll be negative 3 minus 2 in the top over 3 times negative 3, and then plus a 3 in the bottom. So we get negative 5 over, that's going to be negative 9 plus 3, oops, and that'll be negative 6. So that's positive 5, 6, so a little bit less than 1. So if we plug in negative 2, we get positive 5, 6. That's just under 1, so we get a point right about there. Now, again, you could plug in more coordinates, but I think what you're going to find is these coordinates get closer and closer to the horizontal asymptote 1/3, but never quite get there. And as you move to the right, you're forced upwards towards the vertical asymptote like that. So it's still the same looking graph. It's still a hyperbola like the ones you graphed before, but it's a little bit different how you get it. The domain, all but the vertical asymptote, all but x cannot be equal to negative 1, and the range is going to be all reals, all but, oops, all reals but, let's see if I can get the right tool here, all reals besides y cannot equal to 1/3. That was the only output we can't get. And I'm going to leave you guys to try part B on your own and see how you do with that one. And try domain and range. Good luck with that. And we'll talk about using rational functions in real life later on. Thanks for watching, guys, and just have those two graphs ready for tomorrow.